Item number 1 of the quiz, we are to determine the force in each member of the truss. State if the members are in tension or compression. So we have here a simple truss, and it has 5 members: member AB, member BC, member CD, member DA, and member BD. So we are to determine each forces acting on these members, and also to identify if it is compression or tension. So member AB has a dimension of 4 feet. Likewise with member BC, it has a dimension of 4 feet. And then member DB also has a dimension of 4 feet. And then notice that there is a horizontal force acting at point D, which is equivalent to 450 pounds. So the first thing that we have to do is to solve for the reaction. And the reaction is acting on the support. So we have here a roller support, and we also have here a hinge support. So for a roller support, there is only one reaction. So let's label that as A's of V, vertical reaction at point A. And then for the hinge support, there are two reactions acting on it, horizontal and vertical reaction. So for the vertical reaction, let's label that as C's of V. And then for the horizontal reaction, let's label that as C's of H. So notice that these directions are just assumptions, and we'll be able to verify this one once we have the values for these reactions. So for this horizontal reaction, I already assumed that it's moving away from this point B, because if we are going to observe the system, there is only one horizontal force acting towards point B, and the principle of equilibrium, it has to be balanced. So if the force is acting here, we are assuming that the other horizontal force is moving away as well. Again, it's not always the case, but we can verify it after solving the values. So to start, let's solve for the value of A's of B by summing the moment of the forces at point C. So summation of moment at point C to eliminate C's of H and C's of V. So there are only two forces left. Vertical reaction at point A, which is unknown, and then the given horizontal force. So summation of moment at point C is equal to 0, setting clockwise direction as positive. So let's start with the force AV. So force AV, moment at point C. So the direction is clockwise, so that becomes positive. So A's of V multiplied by the perpendicular distance, which is 4. So A to B is 4, B to C is 4. So that's 8. And then considering force, this horizontal force, summation of moment of this force at point C. So the direction is counterclockwise. So that becomes negative, because our assumption is clockwise direction positive. So that becomes negative 450 times the perpendicular distance, which is 4. And there are no other forces, so that's equal to 0. So simplifying, A's of V is equal to 225 pounds, and it's positive. So our assumption of the direction that AV is going up is correct. Next, Summation of forces vertical is equal to 0. Going up, positive. So there are only two vertical forces acting, Ace of V and Cis of V. So for the Ace of V, we already solved the value to be 225 pounds. So that becomes Ace of V is going up, so positive 225 plus. So our assumption for the direction of Cis of V is going up, so plus Cis of V. And there are no other vertical forces acting on the system, so that becomes equals 0. So simplifying, CV now is negative 225 pounds. So the negative sign indicates that our assumption of the direction is wrong. So correcting it, CV is equal to 225 pounds going down. Okay, so we can correct our assumption that's supposed to be going down. Then finally, summation of forces horizontal is equal to 0. Setting going to the right as positive. So from the system, there are only horizontal forces acting. So that becomes Cis of H positive because it's going to the right, minus 450, why 450? Because it's going to the left, is equal to 0. Cis of H is equal to 450 pounds going to the right, and our assumption of the direction is correct. Okay, so these are now the reactions of the system. So we can write that as Ace of V is equal to 225, Cis of V, that's also 225, and Cis of H is equal to 400. So since we already solved the reactions, we can now proceed to solve for the forces on each of the member by using method of joints. So let's start with the joint that has a least unknown value. So we can start with either joint A or joint C, but we cannot start at joint D because sa joint D, maraming unknown. We do not know this force, we do not know this force, we also do not know the force acting on this member. So let's start with the joint that has a least unknown members. So let's start with joint A. So for joint A, what are the forces acting? We have 225. Then we have member AB, assuming that it's moving away. Then we also have here member AD, assuming that it's moving towards point A. So why did we assume that it's moving towards point A? For principles of equilibrium, so if this is going up, force above should be going down to attain balance. Okay, so we can solve the value of AD by using summation of forces vertical, and then we can solve for the value of AB by using the other equilibrium equation, which is summation of forces horizontal. So this has a slope, this is 4, this is also 4, so the hypotenuse is 4 square root of 2. So we can start. Summation of forces vertical is equal to 0. Setting going up as positive. So what are the forces involved? This one and this one. So 2 to 5 is going up, so it's positive. Minus, because force AD is going down. So break it down into its vertical component. So that becomes the slope 4 over 4 square root of 2 multiplied by member AD is equal to 0. So simplifying, AD now is equal to positive 318.198. So since it's positive, meaning to say our assumed direction is correct. So therefore, this is compression. So member AD is already solved. Next is to solve for member AB. So to solve for member AB, we will be using summation of forces horizontal is equal to 0, setting going to the right as positive. So that becomes positive AB because AB is going to the right, minus, why minus? Because AD, horizontal component of AD is going to the left. So that becomes the slope, which is 4 over 4 square root of 2 multiplied by the value of AD, which has been solved to be 318.918. So that becomes 318.198. There are no other horizontal forces acting, so that's equal to 0. So if we transpose this value on the other side, negative becomes positive. So AB now is equal to 225 pounds. So it's positive, so meaning to say our assumed direction is correct. That now becomes tension. Okay, so AB now has been solved. So we are left with 3 members. So I've placed here the values of solved members for our reference. So next is considering adjoint C. So that becomes adjoint C. So for the joint C, we have Cs of V, and that is 225. We also have Cs of H, which is equal to 450. And then the unknown members. So this member is member BC. So since this is going to the right, I'll be assuming that this direction is going to the left. And then we also have member, this is member CD, and since this is going down, we can assume that this is going up. So it has the same slope. If this is 4, This is also 4. This is 4 square root of 2. Okay, so still, we can use summation of forces horizontal, summation of forces vertical to solve for the missing members. So, let's start with the summation of forces vertical. So, summation of forces vertical is equal to 0, setting going up as positive. So, unahin na natin yung vertical component ng member CD. So, para makuha natin yung vertical component, gamitin natin yung slope. So, since it's going up, this is positive. So, that becomes positive, the slope, 4 over 4, the square root of 2, multiplied by the member CD, minus this vertical force is going down, so it's negative. So that becomes minus 225. And there are no other vertical forces, so that's already equal to 0. So CD now becomes 318.198, and it's positive, so meaning to say our assumed direction is correct. So that's tension. So CD has been solved. Next, summation of forces horizontal is equal to 0, setting going to the right as positive. So what are the forces involved? We have horizontal force BC, we have 450, and the horizontal component of this member CD. So that becomes negative BC. Why negative? Because it's going to the left, minus, again, the horizontal component of this one is going to the left, so it's negative. So that becomes 4 over 4 the square root of 2 multiplied by cis of d, but cis of d has been solved to be 318.198, so let's directly substitute it. That becomes 318 multiply 0.198, and then last is this horizontal force going to the right, so it's positive, so that becomes plus 450, and there are no other horizontal forces, so this is equal to 0. So if we are going to simplify that, BC is equal to positive 225 pounds. So since it's positive, meaning to say our assumption of this direction is correct. So that is now tension. So BC has been solved already, and we are now left with member BD. Lastly, we can now solve for the value of member BD. So ito na lang yung kailangan natin. So we can have summation of we can consider joint B, or we can consider joint D, any of the two, but we will be arriving at the same answer. So let's try at joint B. which is the easiest. So at joint B, we have 2 to 5, and then we also have here force 2 to 5, and then we have here member BD, and we can assume any direction. So from here, summation of forces vertical is equal to 0. So obviously, there are no other vertical forces acting on it. So that becomes BD is equal to 0. So let's double check. What about considering at joint D? So this time we will check our answer if it is 0. So considering at joint D. So at joint D, we have force, this is 318198 compression. So compression, so it's moving at point D, and that's 318.198. We also have here force member DC. So DC is 318.198 tension. So since it's tension, this is moving away. This is also 318.198. And then finally, we have the unknown, which is member BD, assuming that it's going up. Okay, so of course, still have the slope 4, 4, and the hypotenuse is 4 square root of 2. So this force is 318.198. So summation of forces vertical is equal to 0, setting going up as positive. So there are 3 forces that we will be considering. First is the vertical component of this force, this vertical member BD, and the vertical component of this force as well. So let's start from here. So since this is going up, this becomes positive. So that's 4. Summation of forces vertical is equal to 0, setting going up as positive. So considering this force, that now becomes 4 over 4 square root of 2 multiplied by 318.198 plus, so positive because BD is our assumption is it's going up, so that becomes plus BD, and then for this force, this is going down, so this becomes negative, so that becomes minus vertical component. We will be using the slope, so 4 over 4 square root of 2 multiplied by this force 318.198. So positive and negative will cancel out, so BD is equal to 0. So tama yung sagot natin dito. Alright, so this member is 0. So you simply have to tabulate your answers. So AB, to have the final answers, let's tabulate. So you have here members, you have here the force, then we have here the type or the nature. So for member AC, member AB. So member AB, that's 225. This is in pounds. So that is tension. Next, member AD, that's 318.198. That is compression. Member BC, that's 225. Tension. Member BD, that's 0. And then member CD, that's 318.198 compression. So this is now the final answer. So for the pointing, for the scoring, this is 2 points and 1 point. So 2 points, 1 point, 2 points, 1 point. This is 3 points. This is 2 points. This is 1 point for a total of 15 points.